we left off with example 3. We had taken our time, we had used the quotient rule to find the derivative, and we had reached the point of the derivative of f of x is 1 over 1 minus sine x. Our job was to write an equation of the tangent line. So what do we need to do to write an equation of the tangent line?
So 1 over 1 minus sine x, x plus 1. Like, I can't say it how I wrote it. Like, you write the slope. We got the 1 over 1 minus sine x. Y equals 1 over 1 minus sine x.
Mm-hmm.
Then you add a second x, because like that's the variable, plus 1 for the y-intercept.
Let's back this up and actually find the slope. This is not the physical slope.
Sure it is.
Oh, well, it is, but it represents the slope of the entire tangent line, or the slope of the entire curve. We want to know the slope where? We want to know the slope at
0.
this particular point. So to find the slope at that particular point, we need to plug in 0. So in order to find our slope, we're going to do f prime of 0. So that's going to be 1 over 1 minus sine of 0, which sine of 0 is 0. So 1 over 1 minus 0 is going to be,
So y just
1?
equals x plus 1, no parentheses.
oh, I see what you're saying. Okay, yeah. So then, yeah, if you put it in the equation format, if I do y equals, and then it's a slope, okay, so slope of 1 officially times x minus 0 plus 1. Yes, we could clean that up and say y equals x plus 1. Okay? Okay. Are we good there? Okay. We're going to do maybe half of these. I don't know. Maybe I should even just do one. We'll see. They ask us to use the quotient rule to develop the rules for the remaining trig functions. You know the derivative of sine right now, and you know the derivative of cosine. And those are supposed to be locking into your memory, which I think you both have done pretty well. So we're going to try and basically develop them, use a proof, rewrite each of the functions in terms of sine and cosine, and then differentiate. So as we start looking at this first one, what do you know about cosecant? How is it related to sine or cosine?
Cosecant is 1 over sine.
So we're going to rewrite this as 1 over sine theta. And then our job is to find the derivative. When we find that derivative, that will be our shortcut. You just memorize it.
Just 1 over cosine theta.
So f prime of theta. No, it's not just 1 over cosine theta. What do we have to use? What are we learning in this lesson? Quotient rule. So you have to use the quotient rule here. Okay. So derivative of the top. What's the derivative of the top? 0 times the denominator, which I'm going to go ahead and write it in. Quotient rule says we subtract. And now it's going to be keep the numerator. And what's the derivative of sine?
Cosine.
Cosine. All over the denominator squared, which is
Sine squared theta.
sine squared theta. I wrote my sine theta parentheses squared. It's the same. It's fine. Okay, let's clean this up a little bit. What does my numerator become?
negative 1 cosine theta, or just negative cosine theta?
Yep. Negative cosine theta over sine squared theta, yes. Or sine theta squared, quantity squared. Now, here's the deal. This is not what we know our derivative to be. I mean, it's an equivalent form, but it's not what we know our derivative to be. We're going to do a little rewrite here.
Why do you read like that? Why is it not sine squared thing?
It's the equivalent. It's fine. I'm getting ready to separate them out. So I'm going to split this into two fractions. We know sine squared theta is what? Sine theta times sine theta. So my denominators are both going to be sine theta. Now, on one of my numerators, I'm just going to put a negative 1, and my other one is going to be cosine theta. I haven't changed the meaning of it, have I? I've changed the form of it, but it's still equivalent, right?
And cosine over sine or cosine.
And 1 over sine is what?
Cosecant.
And so negative cosecant theta, cotangent theta is our derivative.
Yeah, and I
So, what you're going to memorize is that the derivative of cosecant theta is negative cosecant theta cotangent theta. Okay? Now, we can do this with all of them. And on a normal day, I definitely would. Now, there's part of me in a way that says if you know the derivative of cosecant, you kind of know the derivative of secant. Then that they relate. I'm just going to tell you the derivative of secant if you can handle that. If we had worked this one out, the derivative of secant theta would be secant theta tangent theta. The difference is it's positive. Okay? And obviously we would have started this one as secant is 1 over cosine theta, and we would have gone through the same steps. Okay? Tangent theta, how would we start that one? What would our setup be here?
sine over cosine.
Okay, so if we're trying to go for sine over cosines, tangent theta would be sine theta over cosine theta.
So then it would be like sine theta times negative sine theta minus.
Wait. You have to start with the derivative of the top times the denominator.
So cosine theta times cosine theta minus sine theta times negative sine theta. So basically.
Wait. Something didn't sound right there. And it's because I'm writing things wrong. Okay. Sorry.
Sine theta.
Derivative of sine theta is.
See, you got me on. I had it right the first time.
No.
No, I just said it right. Then you got
I know. You had it right the middle time. Okay, so derivative of sine is cosine. Times the denominator, cosine theta. Minus
sine theta times negative sine theta.
Derivative of sine theta, or keep the sine, times derivative of cosine, which is negative sine theta.
Yes.
All over cosine squared theta. Clean it up, and we end up with cosine squared theta plus sine squared theta all over cosine squared theta.
1 over cosine squared theta.
Top is a Pythagorean identity. So now cosine squared plus sine squared is 1. So 1 over cosine squared theta. And 1 over cosine squared theta is better written as secant squared theta. The derivative of tangent is secant squared. Now, if we were going to do cotangent, we would start with cosine over sine. But I'm hoping you guys are okay with me just jumping. You want to take guesses?
Negative cosecant squared theta.
Good guessing. So does that mean we're seeing a little bit of connection there? Okay. It's not just, we didn't just do 4 totally random different ones. They have some overlap in their patterns. Okay, top of the next page is a chart to just collect all of these answers in. Okay, derivative of sine is?
Cosine theta.
Derivative of cosine theta is? Derivative of tangent theta? Secant squared theta. Derivative of cosecant theta?
Negative cosecant theta tangent theta or cotangent theta.
Derivative of secant theta?
Secant theta tangent theta.
And derivative of cotangent theta?
Negative cosecant.
Negative cosecant squared theta. I don't know if this is helpful or not, but if you want a fun little tip, all of my functions that begin with C. So cosine, cosecant, and cotangent. All 3 derivatives are negative. I don't know if that's helpful to you or not as you're trying to sort it all out, but anytime you take the derivative of a trig function that begins with C, you're going to get a negative response. Okay? That's helpful, great. If not, forget I ever said it. Okay. In this next section, it talks about, I don't know if I like it, decomposing fractions with single term denominators using the constant multiple rule to rewrite. Basically, it's talking about ways we can rewrite these in a different form before we take the derivative. As we look at that first one, okay, if you really wanted to, you could take the derivative as is, and you would be using the quotient rule. Now, I'm not saying there's anything wrong with that, but I do feel like people tend to go for the product rule over the quotient rule. Okay? How could we rewrite this? What can we do with that denominator? How could that denominator rewrite?
X to the negative 1/2.
Except it's not just x.
It's
Yeah. So we could rewrite this as y equals x minus 4 to the negative 1/2. And I guess technically we don't know chain rule yet, but I guess it doesn't matter. Okay. So, derivative of this one. What would you do? The power is what?
Negative 1/2.
So what do we do with that?
And it was the front. No, you multiplied in front first.
oh,
And then you should
Depending on which step you're talking about. So move the negative 1/2 out front.
the
X minus 4 is going to stay x minus 4.
minus 4 to the negative 3/2.
And this is where we're subtracting the 1.
So then it becomes -1 over 2 parentheses x minus 4 3/2 to the 3/2 power.
Works for me. Okay. What about this next one? How can we rewrite before we take the derivative?
Maybe just be 6x to the 5/2 minus e to the x
Times
x to the.
I don't know if I like where we're going with this. I don't like this problem in general, but think about that. We have a single denominator x here. Take each term and divide it by x. So, in other words, first one, what is 6x to the 5/2
6 to the 5/2
divided by x?
6 to the 5/2.
No.
6 to the 3/2.
6 what to the 3/2?
X to the 3/2.
6x. So you've got like an x to the 5/2 divided by an x to the first. Subtract. And we can think of this as 6x to the 3/2.
And minus.
Now this one, the cleanup isn't as neat. Because we have an e to the x.
E.
No, it's e to the x. And that doesn't really combine with x. So this one we can take up and put it as x to the, when we take an x out of the denominator, it becomes x to the negative first, e to the x. Well, supposedly it's supposed to make things a little neater. I'm not so convinced on sometimes.
I was about to say, I think I'd rather do
The quotient rule.
quotient on this.
And I wouldn't be against it. I think sometimes you have to look at where we headed for the end result. That's what is going to matter. So, with that in mind, you can do this, yes? Now,
9x to the 1/2.
is that what 3/2 times 6 is?
Pretty sure.
Yeah.
Okay.
Because 6 times 2 would be 12.
My brain just hadn't done it yet. Now, what's the catch on this second part?
I don't even know. It's 2 things
It's-
multiplied together, so you add them together.
It's two things. When two things are multiplied together, to take the derivative, we have to employ the product rule. Okay. Now, with that in mind, I'm going to say we're going to be subtracting this whole thing. So derivative of the first term, so derivative of x to the negative first,
Is 1 over x squared.
well, except I have mine as negative.
-1 over x squared.
Yeah, I just didn't write it that way yet, but yeah. And then, so that's derivative of the first term, keep the second, so times e to the x. And that's a product rule, so plus. And then keep x to the negative first, and derivative of e to the x is
E to the x.
e to the x. Okay, 9x to the 1/2. I'm going to keep 9x to the 1/2. Now, as I rewrite this out, I'm going to distribute, and I'm going to make some fractions. Okay, so first of all, minus times a negative is going to be a plus. X to the negative 2, Logan already mentioned it's x squared on bottom. E to the x can stay on top, so I'm going to write this as e to the x over x squared.
Mm-hmm.
And then I'm going to distribute that minus sign from the front again. Minus times a plus is a minus. This one's going to be e to the x over x to the first. Okay. Can I skip the next one? I mean, it's dividing. Square root of x is x to the 1/2. Can you divide each of those?
So it becomes 6x to the 8 plus x to the 6 minus 2x squared.
Whoa, no. Not what I meant divide. So, well, what is x to the 4th divided by x to the 1/2?
X to the 3. It'd be x to the 7/2.
Yeah.
Yeah. And then this next one, x to the third divided by x to the half.
X to the 5 halves minus 2x to the 1 half.
And you could do the derivative of that pretty easy, right?
Yeah.
Okay, I'm moving on because I'm at 10 minutes and still a page to go. You'll notice right here, okay, this is kind of a lead-in, but they introduce a little bit about our physics lesson, which starts tomorrow. And so, higher order derivatives. I already hinted at, we've just been doing first derivatives. There's also something called second derivatives, third derivatives, fourth derivatives. I could actually find the 100th derivative. Okay, so with that in mind, how that relates to physics, okay? The position function is your base function, often referred to as S of t. Now, the derivative of position is velocity. So if you know position, then if you can find s prime of t, the derivative of position, you now know the velocity function. So I would say the velocity is the first derivative of position. Acceleration is the derivative of velocity. So a of t acceleration, notice it's the derivative of velocity, it's v prime, or notice it's s double prime t. S double prime means the second derivative. And that's what I'm going to show you on the next page here. Okay, at the top of the next page, there's a chart. Okay, you guys are familiar with first derivative stuff. Y prime, f prime of x, you send a little dy dx, right? Or to take the d dx, take the derivative of f of x. Ways to represent second derivative is usually double prime marks. Or this one, it becomes d squared y over dx squared. Triple prime marks, 3's. Once you get past triple prime marks, they don't do prime marks anymore. They just do a little number, kind of looks like an exponent. You just have to know we're talking about derivatives, and we can keep going on all day about these. Okay? So, as you look at this chart here, they ask us to find, in example A, find the second derivative, given that f of x is listed. Well, with this particular problem, in order to find the second derivative, guess what we have to do first?
The first derivative.
Find the first derivative. Okay?
So the second one, you have to do it 5 times.
Yes. But no, I'm not going 32 times or 867 times.
I think that.
Okay, so on A, let's just practice real quick. They give us f of x. What's f prime of x?
Prime of x is, would be like 4 halves x. No. No, it'd be 9 over 2. Yeah.
Yeah.
4.5, but we're going to say 9.5.
Yeah, I know. 5, right? Yeah.
9.5 x squared.
X squared plus 10x minus 6. Yeah.
Okay. Now, we don't stop there because they asked me to find the second derivative. So go another step. It's that easy.
On this one, say.
Exactly.
So this one equals just 9x plus 10.
Notice each time, in a polynomial setting like this, the derivative gets shorter each time, doesn't it?
Yeah.
Okay. So, we're going to go ahead and do B real quick. It goes quicker than what you think. There's no fractions in this one. Give yourself credit. What's the first derivative?
Negative 12x cubed plus 21x squared minus 10.
Second derivative.
30, negative 36x squared
Plus 42x.
42.
Third derivative.
Equals
Negative 72x plus 42.
Fourth derivative.
Negative 72.
so there is no fifth derivative.
Fifth derivative is
0.
0. Okay. Example C. No, we're not finding 32 derivatives. We're going to look.
32 over 32, so wouldn't that make it like...
That's the notation for the 32nd derivative.
So sine, cosine, negative sine, negative cosine.
Okay, so let's go.
Oh, because it's just going to flip back and forth? Or...
We have to look for we're going to find a pattern.
Yeah.
Yep, there's a pattern. So, what's the first derivative?
So basically, once we get to like the fourth, right?
You're killing it, but yes.
Yeah.
What's the derivative of cosine?
I was just thinking multiples.
Negative sine. What's the derivative of negative sine? What's the derivative of negative cosine?
Negative cosine would just be sine.
What's the derivative of sine?
Cosine.
Did we find a pattern?
Yeah.
Yeah. So what you're looking at right here is there's a pattern. That's what I need you to notice there. Now, what about our answer?
It would just be sine. Because if you go on the fourth one, if you do that 8 more times, you're going to be on that same fourth one. So it'd just be sine x.
32 is a multiple of 4, yes. So basically look for your closest multiple of 4 and then count forward however you need to. But yeah, you're going to end up with the 32nd is going to be sine x. Okay? Now, I kind of want to do D real quick because it makes us think a little bit more. 32 is obvious, right? 4 times 8 is 32.
I'm assuming we're just going to divide it by 4.
And look at the remainder. Yep.
Yeah.
So first derivative of cosine is
Negative sine.
negative sine. Second derivative of negative sine is negative cosine. Third derivative of negative cosine is
Sine.
sine. Fourth derivative. And we're back at the beginning, so there's our pattern, yes? Now, 32 is easy because I know 4 times 8 is 32. 867? My brain doesn't have. If I divide by 4.
$216, remainder 3.
Yep. What's the important part about that?
So it'd be sine.
Remainder 3, right? So at the 216th time, we're going to be at cosine. And then we have to go 1, 2, 3 more. Does that make sense?
So basically, it's just going to be sine of x.
So the 867th derivative is going to be sine x. As I said, I knew I could get you guys the basics here.
Yeah.
I knew I could get you guys the basics. What I can't get probably is example 7. Trying to think. Potato launcher fires a potato downward from the top of a 112-foot building. Oh my gosh, Logan. The potato hits the ground in 2 seconds. Find the initial velocity of the potato. The position function is given. And basically, they want you to find initial velocity, which means they want you to find that V naught. Okay, so you're going to take that equation, and we're finding the initial velocity. And what do we know? The potato hits the ground in 2 seconds. So, first of all, can we find S of 2? Yes. Negative 16 times 2 squared plus V naught times 2 plus 112. And what's that going to equal? it hits the ground in 2 seconds. What's its position in 2 seconds?
0.
It equals 0. Okay, you would do the math, you would solve for V naught, and you would end up with negative 24. Okay, I know I didn't give you guys any time to process that on your own. And it's negative because
It's decreasing.
it fires a potato downward. Okay,
That was. I feel like I've done some of this.
okay, you have homework. Get it done for tomorrow. If you normally do homework in 5th or 6th hour, don't count on it. You'll be in a convocation majority of that time. So, and then we will start into lesson 7, which will take us the rest of the week.